Okay, so let's continue on. So we learned to read, we learned to write to the file. We learned that the different modes you can use. And there's one more thing that we need to learn is how to delete file. Okay, this is the dangerous one. So be careful. Because there's no undo. Okay, there's no undo. There's no warning. Once you delete, it's gone. So be really careful when you do this. So let's just say I'm going to delete the new file called new quotes.txt. And that is by going to do as follows. I'm going to, it's kind of messy now. I'm going to just close all of these here. I say I open the file. Yeah, reading, print that out, and the new file, open that. Yeah, we're not going to open that new file. We're just going to delete it, okay? So we remove that. And then down here, yeah, nothing is there. Okay, good. So we're going to push all of these down, okay? This part here, yeah, I think we don't need it either. No more reading here. Okay, this is for deleting files. And so normally, when you want to delete file, you always prompt the user, are you sure, right? But let's just say we don't really care about that, we're going to delete it. Okay, so in order to delete files, you need to import a library into the program. So you can do that by putting here, or you put at the very top. Usually, you put all your imports at the very top of your file. So up here, you can put import a library called OS for operating system. And this OS have access to your files, your directories. You can delete directories, create new directories in your program programmatically, check what kind of files you have in your directories, and so forth. So it's all go to this OS library. So to delete files, we need to go down here and just say, very simple, just os.path. No, just remove it. os.remove, and then just remove the file. And then that's it. Right? I told you, it's very simple in Python. So remove, and then the new file is called new quotes.txt. If it exists. If it doesn't, just doesn't find it, some error. But I think if you just do that, then it should just remove it. And there you go, it's gone. There's no warning. Okay, there's no recovery here. Undo. Maybe over here, I guess, I'm not sure you can do it like in undo, maybe. I don't know if it let you do it. No. Okay, it's done automatically, so just be really careful when you do that. And well, I'm going to put it back. so yeah, it doesn't matter. This doesn't exist anymore. Do you want to close it? No, I'm going to copy this first. Let's say close that, and then just make another one really quick. Okay, so same one, new quotes. Should have made a backup copy. Oh. Okay, the content doesn't matter. This content or not doesn't matter. So usually, so now if I were to go and do another one, let's say I mistyped it. Okay, I put another S here or something. Okay, so extra character, and if you were to delete it, you see that you have an error. Okay, there's no such thing. This is file not found error. So when that happens, your program crashes. Okay.
Is it only looking at files in the current folder?
Because when it's current folder, if you put it in a different directory, you need to put it inside that parentheses. Yeah, so before you delete it, usually you want to check if the file is there. Okay, so you can easily just say if the os.path, okay, path to the file exists. Path including the files. If that file, if I do this intentionally, and that should be false. If it does exist, then go ahead and remove it. Otherwise, you put a message, not found. Okay, so that your program doesn't crash, right? And it kind of handles that kind of gracefully. Actually, no. I have to say path exists. Sorry, you need to check for the exists function. If this file exists, then go ahead and remove it. Otherwise, not found. So we don't have the problems. It doesn't have that ugly error and freaks your customers out. And then now if you go and fix that, then now we can remove it, right? And now it's gone. Okay? So you can check that for any files, just to make sure it exists. And also you can say if the file exists already, then maybe you don't want the user to overwrite it. So you'd say, this file exists already, you can't use it. Give it a different name. Okay, kind of similar with the X thing. X as the mode. Okay. So this example here is a nice segue to the next topic, which is the file exception handling. Not just files, but exception handling. Okay. And most languages have this. So notice again we've had an error here. If I didn't check it, the program crashes. And back to what I had earlier, if I just do that, right, it crashes because there's no file call in there anymore. It's not there anymore. I'm going to just copy and paste. Let's create a new one really quick. Let's just call it ABC for now. It's too long. Okay, ABC. And then just put that there. Of course, it's going to fail because there's no file there. So you can see it has it there, it crashes, and you get this file not found error. So this is one of the types of errors. And you've seen some of these errors before. Right? You have the type errors, you have the out of bounds errors, and you have a invalid index, and division by zero errors, and all those different errors. And so when you have those kind of situations, you have to handle those errors gracefully, right? So your user don't freak out. And so instead of doing this one here, anytime when you write a code, and if your code is like, you're not sure if it's gonna cause an error or not, okay, it's always very safe to put that into what's called a try block. Okay, you try that first. If there's no error, then go ahead and proceed as expected. If there is an error, then you want to catch that. And you catch it by using what's called the except here. So in Python, there are two of them. One's called try except, and one's called try finally. But the except is the one, it captures the exception, which is just another type of error. Okay? And so when you have this type of setup, then if this one is, errored out like it should be, then instead of crashing your program, it's going to jump over to the exception down here, and you can, output a nice message down here. So you can say print file not found, and then your program can still continue on after that, so your program doesn't crash. And let's see if that's the case. You can see that it prints the message and your program continues on. But usually if it doesn't found it, you can say, okay, try again, right? So it's a built-in, built into Python in most languages as well. If you don't do that, you can do like what we just did. If the OS path doesn't exist, then you can still, output any message to the user, which is fine. But this way, it always catches all types of errors. Whichever it finds in here first, because you might have multiple errors in here. This may not be the error, but you might have another one out here, like, for example, let's just say I'm doing total is equal to 12 divided by 0, right? Something like that. And when you do that, of course, this is going to error out because you can't do that division by 0. So you see that that should be the problem. If I didn't catch it, what does it do? It's probably throw an error. It should. Total by 0. You're going to get a division by 0 error. Okay, so this is a type of error. One particular type is called division by 0. This is a, we saw earlier, a found not found error. This is the actual found type of error. So if I put here, except found not found error, I think just like found not found maybe, error. It will print file not found. Where is the error? Let's see, let's try both of those. If file not found error, you'll print that. If it's a different type, except this one is division by 0, so it will find the correct branch and print it there. So you can say print can't divide by 0. Okay? So now, if I run it now, you see that it runs the correct exception. So you can put a list of exceptions here just to make sure you can capture all of them. Okay? So it's a very individual type of error that you can have. File not found, 0 division, and there's another one that it's called the I/O error, or input/output error as well. If you can't, just say, print out to the console, or if you can't write to the file, right? That is an I/O error. So you can put a list of all your exceptions here, and then at the very bottom here, if you don't know what type it is, you can use the default except here. Except here is very broad. This one will capture everything. So the idea is you don't want to put this in the top, because usually if you put it in the very top, it's going to grab that one. It's the catch-all. So that's why you put the very specific ones above it. It's going to go and find every one of those. First, it's going to look at the file division by 0. Look at the first except. Oh, it's not this one. What about the next one? Oh, there it is. Print that. Okay, it goes in there, it prints that block, and then once it's done, it exits out of all the other excepts, and it moves on to the next block of code. But if you put except at the top, then it's going to catch all. So if you put something here, okay. What happened? Oh, must be last. Okay, which is good. Yeah, so it kind of helps you already. Okay, Python does that, which is great, because it should be the last one. Just in case if it doesn't find it, then it will print the last one, which makes a lot of sense. Okay, I think Java does the same thing, if I remember now. It has to be the last one because that's the very broad overall. And if I do something else, let's just say this is legal, and above it here, you do something like, if I say s is equal to ABC, and if I do s, so I'm going to get like print s of 3, right? This is the out-of-bound index. And you see that it's not part of these exceptions at all, because it's an out-of-bound index. It goes to the last one, the catch-all, at the bottom. Okay, so it does that. And it's good to do that because, it makes your code very, much safer, and it's more professional, and it's more reliable. So your customers can buy your program, right? That's important. And then usually in other languages, you put like at the very bottom here, the finally block here. Okay, the finally block, it's not very common in Python to put the except and finally here together, but I mean, again, I think you still can. But this is where you will put any message or any like cleanup in that part. Usually when you open the file to read, and you might run into an error. Maybe when I read the file, I have an invalid character, or have a invalid, I can't read invalid files or something like that in the file, and it throws an error. When it throws an error, something like that in here, then it's going to go ahead and run this one regardless of whether there's an error or not. So it's going to run that, and then usually down here you will close all your files right here. So close your file to save it, or to remove any of these unexpected unclosed streams. So as you can see, it's going to print that out. Because I have an error, it's going to print it out. Whether there's an error or not, it's going to print it out. So I put here the index of 1. So for now, no errors. Well, this one is, but I'm going to comment that out. Comment and remove. And so these 3 statements are no errors. And so it's still going to print the word done. Because this is like, I guess, it's just a required statements at the very bottom of your code here. And it's used for, again, just to clean up your code or clean up everything that you missed inside one of those blocks. Okay? And the book has a list of all the different types of errors you can use. I don't remember which page is it, but I think it's in there. Do I have it here? It's probably about a dozen of them or something like that. So that list of errors, you can use it in your program. So it's very specific. If you don't put it, if you just use the except, then you have to figure out what type of error is it, right? And that's takes a lot of time. Let's just see. Finally, right here, this table here. This chart tells you the different types of errors that Python can throw. Okay, these error exception classes. These are all classes, by the way. Okay, so if it's a class, you can pass data to it. So the exception is the super class or the base class. We'll learn object oriented later in a couple of weeks. Then under that you have 2 classes, the warning. The warning ones are not critical, right? They're not fatal, but the standard errors are. These will cause your program to crash if you don't handle them. So you need a way to handle these errors. And as you can see, we have the I/O error, the arithmetic error, very common for math, runtime error, we were out of memory, and then we have the index error. These are like classes, and then there are more. Overflow error here. You have overflow data and zero division error here, and so on. And then later you can also write your own exception error as well. Your own custom errors. And to force an error to occur, we call that throw. You can throw an error if you want to. Because you can. We call it throw in other contexts like Python, Java, but here you can say we call it raise an error and raise it. Okay. So for example, a common one that you can use is that maybe if I put not string, but if I put for example, if I say n is equal to 12, and if n is say if n is less than 20, that's too small. You can say you can raise an error, raise, and then call one of those classes. You force the error to occur. So you can say what I have to call it the value error. You say that value is not allowed, or it's too small, whatever it is. You say value error, and what that will do is it's going to run the error, it will cause one of these exception to run. So you can do that because you can, right? Otherwise, these are, standard errors in the program by the system. But if you want to control it, you can also raise it, and so that when you run, you see that it has a problem here. It goes to the oops section because I just basically I didn't have the value error down there somewhere. So they put like here value error and print too low. Okay. You see that it goes to the too low block. And print a message there. And next time when we learn classes, which pretty soon, you will write your own class. You can say raise underage error, something like that. And you can throw the error